In this lecture, we will continue our discussion on the list interface. We'll next compare computing the sum of the numbers in a list. So here's some code where we can do that. So we're still going to pass our list of integers, and n is the number of items in this list. So if we take a look here, it's your basic sum method. We have a total that's initialized to 0. We have a for loop where I goes from 0 all the way up to, but not including n. We get the value of the item at position I. We add that to our total, and then once we're done with the loop, we return the total. So how long does this take depending on whether we use array list or linked list? Well, for an array list, this will take O of n time because we can get each item in the list pretty easily. For a linked list, this actually takes O of n squared time. And this is because in a linked list, each call to get is going to take O of n time because we can't directly access each one. So we would have to be a little more creative of how we would traverse through the list each time to get a specific value. Now there is a trick that we could use. We could use a for each loop instead, and this would allow us to have the running time be O of n regardless of whether we use array list or linked list. We should also mention that for both array list and linked list, they're very inefficient with the search methods. So for our case here, if we're using the contains or remove methods from the collection interface, both of them are going to take O of n time. There really isn't anything we can do with it. We just have to use sequential search for both cases. Now with the array list, there's a little bit more we can do with it. There is this notion of a capacity, the maximum size that the array can have. And this represents the size of the underlying array. So what the array list does, it'll actually automatically increase the capacity whenever it's needed, just to make sure that's at least as large as the size of the list. And so the way this is done is if there is an early estimate of the size given to us, if we can find out an early estimate of the size, there is a method in the interface that's called ensure capacity. And what this does is it sets the capacity of the array to be sufficiently large enough. That way we don't need to do a later expansion of the array capacity. So if we need to make adjustments, let's go ahead and do so now. That way we don't have to worry about changing the capacity of the array later on. There is another method called trim to size. And this can be used after all the adds are done to the array list. And we can use this method to avoid wasted space. So if our array is too large, we can use trim to size to cut down the number of elements of the array, so that way we're not wasting any unused space. We're now going to take a look at an example of where we would remove items from the linked list implementation of our list abstract data type. Let's say we want to remove all even valued items in a list. So for example, let's say our list is 65142. The list after we do this method call would be 5 and then 1. What we're going to see is that there's actually more than one way to remove items from a list. One approach we can use is to construct a new list that would contain all of the odd numbers. So then we would just clear the original list and then copy all of the odd numbers from the new list and put it into the original list. That would work, right? The one problem with this is it's very space inefficient. We want to avoid making a copy of the list because we're using up a lot more space than we need to. We would prefer if we can just go through the list and just remove items as we encounter the even numbers. The thing about that though is it doesn't seem like a great idea for the array list implementation, because removing from just about any position is going to be very expensive. Now if we use the linked list approach, there is some hope. We might be able to do a little bit better, because if we remove from a known position, that can be done efficiently because we can just change a couple of the links. Here's the code for our first attempt at removing the even valued items. So we call this method remove evens 1. We're still going to pass our list, and we're using a while loop here instead of a for loop, even though there's somewhat of a fixed number of iterations. And you'll see why in just a bit. But in the while loop, we're saying as long as we're not at the end of the list just yet, we're going to check to see if our current item is an even number. And that's how we do it in this line right here. So list.getI is going to give me the value at position I. And to check if it's an even number, if we just take mod 2 of that and it becomes 0, we know it's an even number. So if it's even, then we're going to call the remove method on the list, and we're going to remove the value at position I. Now, if this isn't true, if it's an odd number, then we just increment I by 1 and move on to the next item of the list. Now, you might be thinking, well, wait a minute, don't we need to move to the next item of the list if we remove anyway? But keep in mind, the way the remove method is going to work, regardless if we use arrays or linked list, is the item at position I is going to be the item that was at position I plus 1. We're going to shove everything over one spot. So when we go back into the while loop and look at list.getI, that's going to be a different item. So we don't need to increment I if we do end up deleting something, because that position is going to have a brand new item. So what's the running time of this method? Well, for arrays, we have a problem because removing is not going to be efficient. We're going to have to spend O of n time just to remove a single item. So that's going to take O of n squared time. Now, what about the linked list? Well, the problem there is going to be with both the get and remove methods. Those are also inefficient. We're going to have to spend O of n time searching the list to find the items to make sure to see if it's an odd or an even number, or to remove the item if it is even. So for linked list, it's also going to take O of n squared time. So we see here for both implementations, this approach is not that great for removing the items in the list.